Welcome students. Today we will do section formula and questions based on section formula. Last class, in the online class, we have done question 1 to 4 on Fair Notebook. So now I am sending all the questions of exercise 7.2. Those who have not done yesterday, you can do now.
Coming to the first question, find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2:3. Moving on to the solution, let the given points be A -1, 7 and B 4, -3. We know that the coordinates of the point R which divides the line segment joining P x1, y1 and Q x2, y2 in the ratio m:n internally is given by R x, y equals to mx2 plus nx1 whole divided by m plus n, my2 plus ny1 whole divided by m plus n. In the question, we need to find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2:3. So the ratio given here is 2:3, which is equal to m:n. So m value is 2 and n value is 3. Here point A can be represented as x1, y1 and point B can be represented as x2, y2. We get the coordinates of C which divides AB in the ratio 2:3 internally by substituting the values of m, n, x1, y1 and x2, y2 in the formula. So Cx, y equals to mx2 plus nx1, which is nothing but 2 times 4 plus 3 times -1 whole divided by m plus n, which is 2 plus 3, m by 2 plus n by 1, that is 2 times -3 plus 3 times 7 whole divided by m plus n, which is nothing but 2 plus 3. So x, y equals to 2 times 4 is 8 plus 3 times -1 is -3 whole divided by 2 plus 3 is 5, 2 times -3 is -6 plus 3 times 7 is 21 whole divided by 2 plus 3 is 5. So x, y equals to 8 minus 3 is 5 whole divided by 5, 21 minus 6 is 15 whole divided by 5. That equals to 5 goes in 5 1 times and 5 goes in 15 3 times. Hence, the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2:3 are 1, 3. Coming to the second question, find the coordinates of the points of trisection of the line segment joining 4, -1 and -2, -3. Moving on to the solution, let the given points be A 4, -1 and B -2, -3. We need to find the coordinates of the points of trisection of the line segment AB. Let C and D be the points of trisection of AB. That means AC equals to CD equals to DB. Here it is clearly seen that C divides AB in the ratio 1:2 internally and D divides AB in the ratio 2:1 internally. We know that the coordinates of the point R which divides the line segment joining P x1, y1 and Q x2, y2 in the ratio m:n internally is given by R x, y equals to mx2 plus nx1 whole divided by m plus n, my2 plus ny1 whole divided by m plus n. Here we can represent point A as x1, y1 and the point B as x2, y2. Let us take the point C, which divides AB in the ratio 1:2 internally. So m is 1 here and n equals to 2. Substituting the values of x1, y1, x2, y2 and m and n in the formula, we get the coordinates of C as C x, y equals to mx2 plus nx1, which is nothing but 1 times of minus 2 plus 2 times of 4 whole divided by m plus n is nothing but 1 plus 2, comma my2 plus ny1, which is 1 times minus 3 plus 2 times minus 1 whole divided by m plus n, which is 1 plus 2. That equals to minus 2 plus 2 times 4 is 8. So minus 2 plus 8 is 6 whole divided by 1 plus 2 is 3, comma minus 3 plus 1 time minus 3 plus 2 times minus 1 is minus 2. So minus 3 minus 2 is minus 5 whole divided by 1 plus 2 is 3. That equals to 2, comma minus 5 by 3. The point D divides AB in the ratio 2:1 internally. So now we can take m value as 2 and n value as 1. Substituting m, n, x1, y1 and x2, y2 in the section formula, we get the coordinates of D as D x, y equals to mx2 plus nx1, that is 2 times minus 2 plus 1 times 4 whole divided by m plus n, which is nothing but 2 plus 1, comma my2 plus ny1, that is 2 times minus 3 plus 1 times minus 1 whole divided by m plus n, which is 2 plus 1, which is equal to 2 times minus 2 is minus 4 plus 1 times 4 is 4 whole divided by 2 plus 1 is 3, comma 2 times minus 3 is minus 6 plus 1 times minus 1 is minus 1 whole divided by 2 plus 1 is 3. That is equal to 4 minus 4 is 0, 0 whole divided by 3 is also 0, comma minus 6 minus 1 is minus 7, so minus 7 whole divided by 3. Hence, the coordinates of the points of trisection of line segment AB are 2, minus 5 by 3 and 0, minus 7 by 3. Let us read the third question. To conduct sports day activities in your rectangular shaped school ground ABCD, lines have been drawn with chalk powder at a distance of 1 meter each. 100 flower pots have been placed at a distance of 1 meter from each other along AD as shown in figure 7.12. Niharika runs 1/4 the distance AD on the second line and posts a green flag. Preet runs 1/5 the distance AD on the 8th line and posts a red flag. What is the distance between both the flags? If Rashmi has to post a blue flag exactly halfway between the line segment joining the two flags, where should she post her flag? Moving on to the solution, let us assume that the bottom left corner of the ground ABCD as origin, so the coordinates of A will be 0, 0. The horizontal line AB be the x-axis and the vertical line AD be the y-axis. Lines have been drawn with the chalk powder at a distance of 1 meter each. That is, each unit on the x-axis represents 1 meter. 100 flower pots have been placed at a distance of 1 meter from each other along AD. That means each unit on the y-axis also represents the 1 meter. Since 100 flower pots have been placed, AD becomes 100 meters. Let us locate the position of green flag and red flag on the xy plane. Niharika runs 1/4 the distance AD on the second line and posts a green flag. So, the green flag is located at a distance of 2 meters from the y-axis. That means its x-coordinate would be 2. Also, it is located at a distance of AD by 4, that is 100 by 4, which is nothing but 25 meters. 25 meters from the x-axis. That means its y-coordinate will be 25. Preet runs 1/5 the distance AD on the 8th line and posts a red flag. So the red flag is at a distance of 8 meters from the y-axis. That means its x-coordinate will be 8. Also, it is at a distance of AD by 5, that is 100 by 5, which is nothing but 20 meters from the x-axis. That means its y-coordinate will be 20. We know that the distance between 2 points P x1, y1 and Q x2, y2 is given by PQ equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. The distance between the two flags is given by under root of 8 minus 2 whole square plus 20 minus 25 whole square, which is equal to under root of 8 minus 2 is 6 square plus 20 minus 25 is minus 5 square, that equals to under root of 6 square is 36 plus minus 5 square is 25, which is nothing but root 61. Hence, the distance between the two flags, that is the red flag and the green flag, is root 61 meters. Also, the blue flag must be posted by Rashmi exactly halfway between the line segment joining the two flags. That is, it must be posted at the midpoint of the line joining the 2 points whose coordinates are given by x1 plus x2 whole divided by 2, comma y1 plus y2 whole divided by 2, that is 2 plus 8 whole divided by 2, comma 25 plus 20 whole divided by 2, which is 2 plus 8 is 10, so 10 divided by 2, comma 25 plus 20 is 45 whole divided by 2, which is nothing but 5, 22.5. Hence, from this we can say that Rashmi must post her blue flag on 5th line at a distance of 22.5 meters from AB. Let us read the fourth question. Find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. Let's have the solution for this problem. Let the given points be A -3, 10, B 6, -8 and C -1, 6. We need to find the ratio in which C divides the line segment AB. We know that the coordinates of the point R, which divides the line segment joining P x1, y1 and Q x2, y2 in the ratio k is to 1 internally is given by R x, y equals to kx2 plus x1 whole divided by k plus 1, ky2 plus y1 whole divided by k plus 1. Here we represent the point A as x1, y1 and the point B as x2, y2. The coordinates of the point C, which divides AB in the ratio k is to 1 internally, is given by C minus 1 comma 6 equals to kx2 plus x1, that is k times 6 plus minus 3 whole divided by k plus 1 comma ky2 plus y1, which is k times minus 8 plus 10 whole divided by k plus 1. Minus 1 comma 6 equals to 6k plus minus 3 whole divided by k plus 1 comma minus 8k plus 10 whole divided by k plus 1. Now let us equate the x coordinates. We have minus 1 equals to 6k minus 3 whole divided by k plus 1. Multiplying k plus 1 on both sides, we get minus 1 times k plus 1 equals to 6k minus 3. Expanding, we get minus k minus 1 equals to 6k minus 3. This implies 6k plus k equals to minus 1 plus 3, which implies 6k plus k is 7k equals to minus 1 plus 3 is 2, which is nothing but here the k value is 2 divided by 7. Now by equating the y coordinates, we get 6 equals to minus 8k plus 10 whole divided by k plus 1. This implies multiplying by k plus 1 on both sides, we get 6 times k plus 1 equals to minus 8k plus 10. This implies expanding, we get 6k plus 6 equals to minus 8k plus 10. This implies 6k plus 8k equals to 10 minus 6, which implies 6k plus 8k is 14k equals to 10 minus 6 is 4. This implies k equals to 4 divided by 14. 2 is here 2 is common factor for both numerator and denominator. So 2 goes in 4 2 times and 2 goes in 14 2 times 7 times. Hence the value of k is 2 by 7. The ratio in which the line segment joining the points A and B is divided by minus 1 comma 6 is 2 is to 7 internally. Coming to the question number 5, find the ratio in which the line segment joining A 1 comma minus 5 and B minus 4 comma 5 is divided by the x-axis. Also find the coordinates of the point of division. Moving on to the solution, let the given points be A 1 comma minus 5 and B minus 4 comma 5. We know that the coordinates of the point R, which divides the line segment joining P x1 comma y1 and Q x2 comma y2 in the ratio k is to 1 internally is given by R x comma y equals to kx2 plus x1 whole divided by k plus 1 comma ky2 plus y1 whole divided by k plus 1. Here we can represent point A as x1 comma y1 and the point B as x2 comma y2. The coordinates of the point C, which divides AB in the ratio k is to 1, is given by C x comma y equals to kx2 plus x1, which is nothing but k times minus 4 plus 1 whole divided by k plus 1 comma ky2 plus y1, which is 5 times k plus minus 5 whole divided by k plus 1, which is equal to minus 4k plus 1 whole divided by k plus 1 comma 5k minus 5 whole divided by k plus 1. But since this point lies on the x-axis, its y coordinate must be 0, that is 5k minus 5 whole divided by k plus 1 must be equal to 0. This implies 5k minus 5 equals to 0. This implies 5k equals to 5. which means k equals to 1. Substituting k value as 1, we get the coordinates of C as C x comma y equals to minus 4 plus 1 whole divided by 1 plus 1 comma 5 minus 5 whole divided by 1 plus 1, which is equal to minus 4 plus 1 is minus 3 whole divided by 1 plus 1 is 2 comma 5 minus 5 is 0, 0 divided by 2 is also 0. Therefore, the ratio in which the line segment joining A 1, minus 5 and B minus 4, 5 is divided by x-axis is 1:1 and the coordinates of the point of division are minus 3 by 2, 0. Coming to the question number 6, if 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find x and y. Moving on to the solution, let the given points be A 1, 2, B 4, y, C x, 6 and D 3, 5, which are the vertices of a parallelogram taken in order. So we need to find the values of x and y. We know that in a parallelogram, the diagonals bisect each other, that is AO equals to OC and DO equals to OB, which means the midpoint of the diagonal AC equals to the midpoint of the diagonal BD. We know that the midpoint of the line segment joining the 2 points P x1, y1 and Q x2, y2 is given by x1 plus x2 whole divided by 2, y1 plus y2 whole divided by 2. So here the midpoint of AC equals to 1 plus x whole divided by 2, 2 plus 6 whole divided by 2. That equals to midpoint of BD is 3 plus 4 whole divided by 2, 5 plus y whole divided by 2. This implies 1 plus x whole divided by 2, 6 plus 2 is 8, so 8 divided by 2 equals to 3 plus 4 is 7, so 7 divided by 2, 5 plus y divided by 2. This implies 1 plus x whole divided by 2, 2 goes in 8 4 times, so 4 times, so 4 equals to 7 divided by 2, 5 plus y whole divided by 2. So first equating the x terms, we get 1 plus x whole divided by 2 equals to 7 divided by 2, and now equating the y terms, we get 4 equals to 5 plus y whole divided by 2. This implies multiplying by 2 on both sides, we get 1 plus x equals to 7, and multiplying by 2 on both sides, we get 2 times 4 is nothing but 8 equals to 5 plus y. This implies x equals to 7 minus 1 and y equals to 8 minus 5. This implies x equals to 7 minus 1 is 6 and y equals to 8 minus 5 is 3. Hence, the values of x and y are 6 and 3. Coming to the 7th question, find the coordinates of a point A where AB is the diameter of a circle whose center is 2, minus 3 and B is 1, 4. Moving on to the solution, here in this problem, the center C is given as 2, minus 3 and one end of the diameter AB is given as B 1, 4. We need to find the coordinates of the point A. We know that the midpoint of the line joining the 2 points P x1, y1 and Q x2, y2 is given by x1 plus x2 whole divided by 2, y1 plus y2 whole divided by 2. We know that the center of the circle will be always the midpoint of the diameter of the circle. So, by the midpoint formula, we have C 2 comma minus 3 equals to x plus 1 whole divided by 2 comma y plus 4 whole divided by 2. This implies first equating the x coordinates, we get 2 equals to x plus 1 whole divided by 2, and now equating the y coordinates, we get minus 3 equals to y plus 4 whole divided by 2. This implies multiplying by 2 on both sides, we get 2 times 2 is 4 equals to x plus 1, and 2 times minus 3 is minus 6 equals to y plus 4. This implies x equals to 4 minus 1 and y equals to minus 6 minus 4. This implies x equals to 4 minus 1 is 3 and y equals to minus 6 minus 4 is minus 10. Hence, the coordinates of the point A are 3, minus 10. Let us read the 8th question. If A and B are minus 2, minus 2 and 2, minus 4 respectively, find the coordinates of P such that AP equals to 3 by 7 AB and P lies on the line segment AB. So moving on to the solution, let the given points be A minus 2, minus 2 and B 2, minus 4. Let the coordinates of the point P be x, y. In the question, it is given that AP equals to 3 by 7 of AB and the P lies on the line segment AB. Let us represent the given data diagrammatically. AP equals to 3 by 7 of, here AB can be written as AP plus PB. This implies multiplying by 7 on both sides, we get 7AP equals to 3 times of AP plus PB. This implies 7AP equals to 3AP plus 3PB. This implies 7AP minus 3AP equals to 3PB. This implies 4AP equals to 3PB. This implies AP by PB equals to 3 by 4. It means the point P divides AB in the ratio 3:4 internally. We know that the coordinates of the point R, which divides the line joining P x1, y1 and Q x2, y2 in the ratio m:n internally is given by R x, y equals to mx2 plus nx1 whole divided by m plus n, my2 plus ny1 whole divided by m plus n. Here, the point P divides AB in the ratio 3:4 internally, that is, the value of m here is 3 and the value of n is 4. We represent the point A as x1, y1 and the point B as x2, y2, and substituting the values of m, n, x1, y1 and x2, y2 in the formula, we get the coordinates of point P x, y equals to mx2 plus nx1, which is nothing but 3 times 2 plus 4 times minus 2 whole divided by m plus n, which is 3 plus 4, my2 plus ny1, which is 3 times minus 4 plus 4 times minus 2 whole divided by 3 plus 4, which is equal to 3 times 2 is 6 plus 4 times minus 2 is minus 8 whole divided by 3 plus 4 is 7, 3 times minus 4 is minus 12 plus 4 times minus 2 is minus 8 whole divided by 3 plus 4 is 7 which is equal to 6 minus 8 is minus 2 whole divided by 7, comma minus 12 minus 8 is minus 20 whole divided by 7. Hence, the coordinates of the point P are minus 2 by 7, comma minus 20 by 7. Coming to the ninth question, find the coordinates of the points which divide the line segment joining A minus 2, 2 and B 2, 8 into 4 equal parts. Moving on to the solution, let the given points be A minus 2, 2 and B 2, 8. We need to find the coordinates of the points which divides line segment AB into 4 equal parts. Let C, D and E be the points such that AC equals to CD equals to DE equals to EB. We know that the coordinates of the point R which divides the line segment joining P x1, y1 and Q x2, y2 is given by R x, y equals to mx2 plus nx1 whole divided by m plus n, my2 plus ny1 whole divided by m plus n. Here the point C divides AB in the ratio 1:3 internally. So m value here is 1 and n value is 3. We represent the point A as x1, y1 and the point B as x2, y2. And by section formula, the coordinates of point C are mx2 plus nx1, that is 1 times of 2 plus 3 times of minus 2 whole divided by m plus n, that is 1 plus 3, my2 plus ny1, which is 1 times of 8 plus 3 times of 2 whole divided by m plus n, that is 1 plus 3, which employs that equals to 1 times of 2 is 2 plus 3 times minus 2 is minus 6 whole divided by 1 plus 3 is 4, 1 times 8 is 8 plus 3 times 2 is 6 whole divided by 1 plus 3 is 4, which is equal to 2 plus minus 6 is minus 4 whole divided by 4, 8 plus 6 is 14 whole divided by 4, which is nothing but 4 goes in minus 4 minus 1 times, here 2 is common factor for both numerator and denominator, so 2 goes in 4 2 times, 2 goes in 14 7 times. Hence, the coordinates of the point C will be minus 1, 7 by 2. The point D divides AB in the ratio 2:2, that is 1:1 internally. That means it will be the midpoint of AB. We know that the midpoint of the line segment joining the 2 points A x1, y1 and B x2, y2 is given by x1 plus x2 whole divided by 2, y1 plus y2 whole divided by 2. So the coordinates of the point D will be D x, y equals to minus 2 plus 2 whole divided by 2, 2 plus 8 whole divided by 2. That equals to minus 2 plus 2 is 0, 0 divided by 2 is 0, 2 plus 8 is 10, 10 divided by 2. That equals to 0, 2 goes in 10 5 times. Hence, the coordinates of the point D are 0, 5. The point E divides AB in the ratio 3:1 internally. So here m value equals to 3 and n value is 1. The coordinates of point E will be mx2 plus nx1, that is 3 times 2 plus 1 times minus 1 times minus 2 whole divided by m plus n, that is 3 plus 1, comma my2 plus ny1, that is 3 times 8 plus 1 times 2 whole divided by m plus n, which is 3 plus 1. This implies the coordinates of E will be 3 times 2 is 6 plus 1 times minus 2 is minus 2 whole divided by 3 plus 1 is 4, comma 3 times 8 is 24 plus 1 times 2 is 2 whole divided by 3 plus 1 is 4. That equals to 6 plus minus 2 is 4 whole divided by 4, comma 24 plus 2 is 26 whole divided by 4. That equals to 4 goes in 4 1 times, comma here we see that the 2 is common factor for both numerator and denominator. So 2 goes in 4 2 times, 2 goes in 26 13 times. Hence the coordinates of the point E will be 1, 13 whole divided by 2. Therefore, the points which divide the line AB into 4 equal parts are C -1, 7 by 2, D 0, 5 and E 1, 13 divided by 2.